Okay, in this video I'm going to do an example problem which asks you to draw some Venn diagrams that satisfy some given conditions here. So for example, the first one, part A, says we want to draw a Venn diagram that satisfies both of these conditions, that A intersect B is the empty set and that C is a subset of B. Okay? Just to go back to the top here, I'm giving you a little bit of help with this and showing you what the Venn diagrams look like. For example, when the intersection of two sets is not equal to the empty set, we're going to draw them overlapping each other so that the intersection is this region where they overlap. So when it says that their intersection is not the empty set, that means they're not disjoint. When their intersection is the empty set, that means they're disjoint and there is no overlap, and so we draw them as circles that are separated with each other, non-overlapping. And by the way, just so you know, we could draw them as any shape we want. Okay, we don't have to be drawing circles or ovals. Circles are convenient, but we can draw any shape we want for our sets. Okay. Let's see, when we draw two sets such that one is a subset of the other, we draw it on the inside. A is a subset of B. A is all the elements of A. Anything that's in A is also within the circle of B. Okay, A is a subset of B. If it tells you that one set is not a subset of the other, the most general case is to just draw them as two general sets and to not also impose some other relationship. Now, both of these pictures over here also satisfy A not being a subset of B, but they also satisfy some additional condition. In the first one, they also satisfy further that B is a subset of A, and in the second one, they also satisfy the further condition that the two sets are disjoint. And so each of these situations, although satisfying A is not a subset of B, has a further condition on it. And this is the one over here, the preferred picture for A not being a subset of B, where we don't have any additional conditions imposed upon the sets. So let me go ahead and do these pictures, and I hope you'll see that they're fairly straightforward and that you can follow the logic through on these. Here I want A intersect B to be equal to the empty set. So I'm going to go ahead and draw A and B as disjoint sets. A and B are disjoint. But then it says C has to be a subset of B. So I'm going to go ahead and put C on the inside of B. And I'm done. Okay? I think that's the only way I can draw that picture. Okay. Next, I had three conditions. A is a subset of B. C is also a subset of B. So A and C are both inside the set B. But A and C are disjoint because their intersection is the empty set. So I'm going to draw B being kind of large here. And then A and C are both in B, but A and C are disjoint, so I won't let A and C overlap. Okay? So there's a picture that satisfies all three of those conditions. A is a subset of B, C is a subset of B, and A and C don't overlap. Next, I have one that says A is a subset of B, C is a subset of B, and A and C do overlap because their intersection is not equal to the empty set. And so I'm just going to draw B out here, A as a subset of B. A is inside B, C is inside B, and the A and C do overlap. For part D, it says A is not a subset of B, so I'm going to go ahead and draw the picture I had above that I recommended for A not being a subset of B, the most general situation. And C is a subset of their intersection. So here's their intersection in this little football-shaped region. So here's the set C. It's in the intersection. Okay, I didn't leave myself really very much room there, but I fit it in, and I labeled it with that little line. Okay, maybe I'll make it into an arrow. Or maybe I'll just So A, B, C. Make it really clear. Okay. Next part. Two conditions. C intersects B is equal to C, and A intersects C is not equal to the empty set. Now just a second. In a previous problem, I talked about this situation where if the intersection of two sets is one of the sets, that means one of them is a subset of the other. And in this case, I think C has to be a subset of B. Let's draw the picture and see if it makes sense. That C is a subset of B. C intersect B is where C and B overlap. B includes everything inside of its circle here. And C is inside here. And so B and C overlap exactly where C is. And so C intersect B is equal to C. So this means that C is a subset of B. So I got it right. If I had drawn the other picture first, so I know it means that one's a subset of the other, and I could just draw both pictures. And here, C and B overlap on B, and so I had drawn the wrong picture, so this one isn't the right one. In any case now, I've satisfied the first condition, C is a subset of B, and A intersects C is not equal to the empty set. There's a number of ways I can do this. I can simply put A here, and make A so that it doesn't intersect with C, or so that it does intersect with C. It kind of also assumes that A is a subset of B, so maybe a more general way of doing that, if I can get rid of all this other stuff here, is to say that, let me try drawing it again with a B here, a C on the inside, and the more general case, if I don't impose any other restrictions, is to let A intersect C and let A also intersect B, and make sure that A is not also a subset of B. It turns out I could do a couple of other different drawings. C, B. I could draw A like this. Then A and C intersect each other. And C happens to be a subset of A. I could also draw B here, C here, and A all the way around. Now A intersects C is still not the empty set, and C is still a subset of B. So there are actually 4 different drawings I could make for this one, and they all work. Just because I didn't quite give enough conditions to narrow it down to any one of those 4 drawings. Next. Part F, I have 3 different conditions I need to meet. A is a subset of B. Okay, I'll go ahead and draw A on the inside of B. B intersects C is not the empty set, so C overlaps with B, but A intersects C is the empty set, so C does not overlap with A. So I need to draw C overlapping with B, but not A. So I draw C like this. Okay, that does it. A and C are disjoint, their intersection is the empty set. B and C are not disjoint, and A is a subset of B. Okay? Next, oh my gosh, I've got 1, 2, 3, 4 conditions. But 3 of them are all looking the same. A intersect B is not the empty set, means A and B overlap with each other. B intersect C is not the empty set, and that means B and C overlap with each other. C intersect A is not the empty set, that means C and A overlap with each other. But here it says there is no triple overlap. The triple intersection is the empty set. So they all overlap with each other, every combination, A with B, B with C, C with A, but they don't overlap all 3. And I actually drew this on the board the other day. You can do this with 3 sort of sets like this, A, B, and C. You can see that I have an overlap between A and B here. It's non-zero. It's not the empty set. B and C are overlapping, not the empty set. A and C are overlapping, or C and A are overlapping. Their intersection is not the empty set. However, all three of them never overlap, and I've got this empty spot in the middle. Okay? This is an example where it's important to realize that you can make these sets any shape you want. Finally, part H. I've got three conditions. The first one is that A intersect B is the empty set. Let's just start with an A and a B that are disjoint. If their intersection is the empty set, they're disjoint. B intersect C is the empty set, and C intersect A is the empty set. None of them intersect with each other. They are mutually disjoint. No matter, there's only three ways I can take them pairwise: A with B, B with C, A with C. And it says they're all intersecting to the empty set, meaning they're all mutually disjoint. Okay? So I hope this helps on this problem and helps with Venn diagrams.